Somehow in this room, we are talking about shipping products that affect everyone. So this is just one small room in San Francisco, but somehow like the lever that we together have in this room affects everyone. And I just wanted to sort of like benchmark the stakes to that because these tokens are going somewhere, and I relied on a lot of products to get here today. Those products need to work. And they need to work whether they're produced by a collection of biological neural networks or whether they're substantially amplified by the other kinds of neural networks that we use. And so that's why I'm just going to talk about scaling validation. So you'll see some of my work published a few months back. You may have seen some of it. I am previously the co-founder and CTO of StrongDM, cybersecurity company in business for about 10 years. And in cybersecurity, correctness is not optional. If your system isn't correct, you have no customers, and you have headlines that say where all your customers go. And so that imbued our AI team when I created it last summer with a sort of obsession about correctness. And it just turned out it was a virtuous obsession that I would encourage all of you to adopt, is to really indulge the what about, the long series of questions of what about security, what about performance, what about durability, what about every what about you can possibly come up with. They end up being virtuous because, in my opinion, you only have what you can validate, right? And the definition of validation is also unfortunately changing because previously we might have been satisfied with a passing test. Now it's much closer to, we really want to get closer to the customer and ask, have I validated that you're willing to pay me for this service? Okay, and to the extent that we can, we're trying to push that validation and get that closer to end, and then really let the rest of our system run. And maybe that's one definition of a software factory. So this talk is going to have basically just one story and then one technique for folks to think about. So the story first. This is written up online, but I'll just enunciate it again. We faced a situation where we had a novel, greenfield-ish agentic flow through the system. But that agentic flow dealt with access control for consequential data, consequential systems. It was something that, like I said, correctness was not optional. It needed to be right. Every time we used uppercase and shouted at the model and said, do it right, obviously that didn't work, okay? So no matter how we asked, the models would eventually cheat, they would eventually reward hack. Everybody knows this now. So we needed to hold out a definition of done that was so vast and so complicated for the model to cheat that the energetically cheaper option was to simply implement the system correctly, okay? And the way we did that was by contemplating all of the interaction surfaces that our agent needed to deliver on. And one of those critical interaction surfaces was Slack in this case. We could have written a unit test or an end-to-end test that touched a Slack API once, one tracer bullet through, and that would have told us something. But it wouldn't tell us whether that URL that we shared in Slack would be received by a potential user and would be accessible by a potential user, and whether it would have the same content as the spreadsheet that we intended to send them. Or that when we shared a Google Drive file, the file would be received by the intended recipient and not available to the non-intended recipient. Or that when the Jira ticket was opened that requested access for any of those objects, whether that would be understood and fulfilled correctly, okay? And so this, to us, the way to raise the stakes for the code generators to that maximum level where the easiest path was to simply solve the problem was to create not a mock, not a one-off, not just a test, but a living, breathing replica of all of these SaaS applications that we were interacting with. And this is what became known as our digital twin universe. And it was a coherent universe because across this universe, the identities that were present were congruent. So the same user that was present in a file share was also present in Slack, was also present in Jira, was also present in Okta. And the traceability of that identity also, because we controlled all of the memory and state for the digital twin universe, it allowed us to replay, it allowed us to create scenarios, it allowed us to branch scenarios, and all of that contributed to, really within the available wall time and token time, it allowed us to create a contour of a context and a token environment where the only answer was the correct answer, okay? But Digital Twin Universe is just one extremely scaled up example of validation. And I will say, it is an important example because, of course, 5 years ago, we all would have wanted a more sophisticated mock environment, a more sophisticated simulation environment. But the prospect of cloning a substantial portion of the surface area of Okta, or of the Google suite, or of Jira, the prospect of cloning that would have been economically infeasible. Any engineering manager would have understood the request and then patted someone on the head and said, great idealism, go back to your corner, keep coding, okay? But today, of course, we can think different. We can have nice things. We can have nice things regarding our obsessions and paranoias about the system. We can indulge the what about questions with tokens. And Digital Twin Universe is one way to do that. A little review about how we've built confidence in previous software vintages. And I do find the McCarthy software vintage numbering pretty useful because when we think about our software 1.0 traditional software, we essentially know how we validated those elements. For those folks that have been substantially involved in training models of any kind, not LLMs, but regular machine learning models, your definition of done, you're already familiar with the idea that there's a threshold involved. It's not Boolean. You're thinking, how do I know this thing is good enough to ship, to discriminate these two signals in some natural environment? You need to do it with these measures. They're measures that characterize the overall observed behavior of the model because the weights that are inside the model are inscrutable after some size, right? And so what I'll say is living with this uncertainty is also, it's familiar from other engineering disciplines, mechanical engineers, electrical engineers. There are error bars around everything, right? And folks have said this before, but this is the first time in software we really have to have a lot more error bars around our processes, and yet we need to create enough redundancy in those systems so that we understand those error bars and can proceed with some confidence. So what I'm claiming here is that our approach to software 3.0 confidence is blending attributes of both of these prior systems, as well as relying on the power of the agents themselves, of course. And with sufficient tokens, and with sufficient design, and sufficient conviction, it is possible to create confidence of systems that are even quite critical for all the billions of folks that we're serving in this room. So I'm going to start out with one way to not build confidence. And I refer to this as just REPLing. So REPLing with Claude, it's a very seductive REPL. It's very nice. The personality is great. It encourages you to stick around. It wants you to just do one more turn. Ultimately, this is not the way. But let's just consider what it looks like. Okay? Yep. Uh-huh. Okay. And then this is the problem. This is the non-scalable event. I'm using my retina tokens. They're extremely finite. They exist in wall time. There's like one or two of them. The parallelism is really poor. I shouldn't be looking at something to know whether it's right, okay? But REPLing with Claude feels good initially. We obviously need more leverage than this. And if you're still doing this, probably stop and probably figure out how to go up an order of magnitude in your leverage. right? And obviously that's the moment we're all in. We're trying to stop and do that every time. Every time something works, that's a signal that you need to increase your ambition. Easy to understand, but gosh, only one, no durable record, and it just burns human tokens, which we should do so sparingly. Okay, so the next level, if you write down your intentions in, Markdown's a format, you write it down in Markdown, that gives the model something to bounce against. It can bounce against it all night, okay? That's great. This is going to give you at least an order of magnitude of leverage, okay? It doesn't matter if you use SpecKit or this is Kiro. It doesn't matter if you're using compound engineering or superpowers. You use any and all of them. Make your own skill. I do it my own way. But encoding your intent in some durable artifact allows you to revisit it, allows the model to revisit it, allows you and the model to contemplate the trajectory that got us here. It can run all night. It can run all day. It can run in the background. It can run while you're specifying the next increment on another piece that you have in motion. And then obviously you're not using your human tokens to validate because you've set your human token intent at the beginning, and then you're awaiting the implications. But it's a lot of markdown. And some of that markdown may be in conflict with other of that markdown, okay? And this isn't a compiler. So it's not going to tell us that we've instructed the building to be both 100 feet tall and 105 feet tall, okay? So we need some way to detect that we're asking for the wrong things. And Markdown alone won't do it, okay? It's passive. It's there in a repo. It's on disk. But it's not a collaborator. So today I'm just introducing the notion of what I'm calling a critic application. And I'm inheriting this nomenclature from reinforcement learning, where the actor-critic dichotomy has led to a productive virtuous loop of creation and critique that actually is like it's in all of the post-training that we all benefit from today. It's not the same thing because this isn't a neural network, but it's the same idea that some minimally adversarial sort of external probe is going to help improve your work, okay? And that probe can be alive. That probe can act like perhaps historically a black box QA team might. That probe can ask questions. That probe can rifle through historical screenshots of how the application looked yesterday or 5 minutes ago or last year, and then compare and contrast, okay? So a critic application is a reactive form of specification. And it can have agentic loops inside of it, right? And it can use the file system, it can use databases, it can use sound and video recording, it can use a computer in all the ways we use computers. We can show examples, and we can say, here are code citations of patterns and algorithms and libraries that work. In fact, just use this library. Don't reinvent this. The Linux kernel works fine. Don't rewrite it unless that's your intent. Here are the 5,000 examples that we have to test against. Okay, fitting 5,000 examples in a Markdown is annoying. Fitting it in an application is normal. I think most importantly, a living application can compress your intent. And one way to imagine this is not universally, not across your company, but for the piece that you're creating, there is a DSL that's the right compression of the design conversation you want to have with the validation harness that you need to run, okay? That DSL, it doesn't have to have a name for that language. It doesn't have to be broadly distributed. It just has to be the right form of leverage for constraining the degrees of freedom for the application you have that you need to generate and you need to emerge. And then critic applications can compensate for model weaknesses. We know the inventory of weaknesses. We know those weaknesses are being retired, but for now, the models, as an example, they don't know how to design agent loops real well because there's not a lot of prior art because they are the prior art. And so you have to put more of your human advice into how to design effective agentic loops. And a critic application can help you do that. This is the RL architecture. So an example from my work last week, I had a series of problems that all dealt with filling and reading and correctly comprehending PDFs, but those PDFs had various forms. There were the correct form fields, there were just visually present form fields, and yet I needed to be able to extract and write to these PDFs regardless of the format they were originally in. Now, this is all possible because there's all forms of multimodal model applications here, and there's a lot of prior art on PDF comprehension. By compiling all of this into sort of the world's greatest expert on all the techniques possible related to authoring and reading PDFs, I was able to create a critic application that made the path to the real final composite that I needed to create, the real end-to-end application, became enormously easier because everything about PDFs just worked. And if it didn't just work, the PDF helper could explain why. And it could explain why in a way that a coding agent could then take action on. Okay? So this was just one tiny component. But the act of one-shotting or end-to-ending, do PDFs right without this, it's infeasible. But by compressing the world's knowledge into a living version of how to best PDF, that's an interesting building block for coding agents to use. And that's the feeling that I think you can begin to expect from part of your software factory. That's the feeling you can begin to expect from your validation loops. Yeah, this was like a really fun thing. Just, hey, draw all the fields. And the underlying PDFs in these cases, like some of them are real fields, some of them aren't, some of them just look like fields. Now it just works. And anything that looks like a PDF has fields and formatting and actually format validation and everything. And I have profound confidence that pretty much any agent that I hand this library to, it's going to nail PDFs. A lot of us have devices that we use to compensate for our weaknesses, so for example, like glasses. A critic application is helping the model see. It's helping the model act. And that's going to make something that would otherwise be impossible straightforward. So mapping areas of the real world that models have difficulty with, if you do it, then this intelligence that we feel on the other side of that prompt, it will be able to follow through further into your business, further into your customer relationships. Feed those specs into this loop, and then just Ralph it. That's great. That's going to work out fine. All right, one bonus level that we recognize at StrongDM and put this into production. If you can understand a log file, if you can understand an error, if you can understand that spending more memory and time is worse than spending less memory and time for a given task, if you can understand that, then the models can probably understand it as well. And so that's another loop that you can close with your production environment. So those observations about what should be improved, what should be fixed, that critic is helpful not at dev time, but at production time. I call these healer loops, because the system has to be self-healing for some deep definition of self-healing, multi-dimensional definition. Regarding memory, regarding durability, regarding cybersecurity. It should be able to heal itself. You obviously have to pursue this with conviction. You can't just download healer.exe, okay? But it can work. All right, that's the talk, folks. REPL, specs, critic, healer loop, and when in doubt, apply more tokens. Thank you, everybody.